All right, so in order to start completing the square, you have to have it in standard form with the x squared and the x on one side, and you can leave that number on the other side. So we're going to first move that 12x over. So we are going to move the 12x over to the other side, subtracting it over. So you will have x squared minus 12x on this side. You will leave the 4 on that side. All right. Then we're going to take that negative 12 and we're going to cut it in half, which is going to give us negative 6. And we're going to square that, which is going to give us 36. That's what we're going to add to both sides. All right. Once we do that, we already know the factoring here because we just created it. My factoring is going to be that x and whatever this was. That's a minus 6 squared. And then we're just going to add that. 4 and 36 is 40. You're going to take the square root of both sides. On the left, it's just going to get rid of your square. So you have x minus 6. On the right, you do have the positive and negative root of 40, but that actually does simplify. So if we were to take 40 and do this out, right, you can see that a 2 will come out, 2 and 5, which is 10, will stay in. So positive and negative 2 squared to 10 is what that simplifies to. And then my last step is to move this 6 over. The 6 cannot combine with that root, so we end up with just a positive 6 plus or minus 2 square root of 10. All right, same concept here. I would actually move it all to the right. So I would keep my x squared positive. So I would move the 10x over here and the 7 over here, right? Because I want to keep that x squared positive if at all possible. So when I subtract the 10x over, I have x squared minus 10x on this side. And when I subtract the 7 to the other side, I have it like that. With equality, you can just flip them. So like if 2 equals x, then x equals 2. Those are the same statements, right? So if you visually need to have it set up with what you're working with on the left and the number on the right, you can just flip them. It doesn't matter. So I can write this x squared minus 10x equals negative 7. That's perfectly fine, right? And now I can do the same process. Take that negative 10, cut it in half. That gives me a negative 5. Square it. That gives me 25. So I'm going to add 25 to this side, and I'm going to add 25 to that side. All right. On the left-hand side, I already know the factoring, right? It's x and whatever this guy was, minus 5 squared. Over here, negative 7 and 25, that's just 18, positive 18. Square root both sides. Remember that 18 can simplify. The 3 comes out, the 2 stays in. So on the left, I have x minus 5. On the right, I have positive or negative 3 square root of 2. And then my final step is just to add that 5 over. Since it cannot combine, that's how I end up with the 5 plus or minus 3 square root of 2. Quadratic formula. So they talk about it at first, and they give you lots of information on it. But the basic of the quadratic formula looks like this. Has to be in standard form. I want to point out a few things here. It has to be ax squared plus bx plus c. What do you notice it is equal to? 0. Okay, so just like in factoring, it has to be equal to 0. So if it is not, you have to move everything over to one side and make it equal to 0. So first thing, has to be in standard form, equal to 0. It says a cannot be equal to 0. If a was equal to 0, you would have a linear equation, y equals mx plus b, and it wouldn't be a quadratic, and there'd be no reason to solve it with a quadratic formula, nor could you, okay? When you see the a, b's, and c's, it is not the variables as well. It is literally just the numbers, the coefficients and the constant. Your quadratic formula should not have a variable in it. You are solving for the variable. X is going to equal whatever happens when you plug in these numbers to the quadratic formula, okay? So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. All right? So negative b, that means whatever b is, do the opposite. If b is positive, you're going to put a negative there. If b is negative, that's going to be positive. Plus or minus, that's because we're talking about a root. And like every other one we've done so far, when we take a root, we do the positive and the negative root. All right? On the inside, b squared minus 4ac, you're going to do order of operations here. Square the b, multiply the 4 times the a times the c, and then do your subtraction. Okay? And then that entire thing is divided by 2 times a, all right? I promise it works every time. Whether it's factorable, whether it's not factorable, completing the square will work. Like, this is going to work every time. All right. Write the equation in standard form. So move anything over. Identify your a, b, and your c. Plug it into the quadratic formula and simplify, all right? I don't know why they have that. So first you have to know it. All right, they're going to give us one that's actually factorable here. So I could factor this one. What would I get if I factored this one? How would I factor? Factors of 6, negative 6, they give me positive 5. One's positive, one's negative. Those are the, yeah. I could factor this. They give me one that is factorable, so you can see that the quadratic formula actually does work, right? You couldn't prove it if I gave you some crazy square root of 85. So looking at this, I think my answer should be negative 6 and positive 1. Yes? Okay, so we're going to do quadratic formula. First thing we check, is it equal to 0? Yes. We're going to identify our A. Our A here is 1. Our B here is 5. Our C is negative 6. You have to use the plus or minus in front of it, okay? So my quadratic formula that I'm sure you all have memorized now looks like this. All right. That is what x equals, okay? That is what x equals. So I'm going to plug it in. Negative b. If my b is 5, I'm going to say negative 5 plus or minus the square root of b squared. That's just 5 squared minus 4 times a times c all over 2 times a. All right. Literally, that's all you do. We're going to do order of operations. So we have negative 5. What is 5 squared?
25.
25. And then I have minus 4 times 1 times negative 6. What is 4 times 1 times negative 6? All right, all over 2 times 1 is just 2. Shh. All right, let's look. 25, this is plus. All right, 25 plus 24. So I have negative 5 plus or minus the square root of what? There we go. Thank you. All right. What is the square root of 49?
7.
Now, when it looks like this, we're going to actually solve it, okay? I can add and subtract 7. If that had been the square root of 7, this would be your answer. You'd be done. But we can actually do this one. So I have negative 5 plus 7 over 2, right? And I have negative 5 minus 7 over, that's not a 7, minus 7 over 2. Negative 5 plus 7 is 2. 2 divided by 2 is 1. Negative 7 minus 7, negative 5 minus 7 is negative 12 divided by 2 is negative 6. That is my answers, okay? Now, clearly, I would not use quadratic formula here. I would use factoring for something like this. The factoring would have been much faster. But I'm showing you one that you could use factoring for so you can see that it actually does work for those ones that factoring is not something you want to actually try to do. So the first thing is, if it is quadratic formula you're using, what does it have to be equal to? 0. It has to be equal to 0, which means we have to move that 8 over, okay? So we're going to say 3y squared minus 4y minus 8 equals 0. We have to move it over, all right? And then we are going to plug it in. Negative b plus or minus the square root of b squared minus 4 times a times c. And that is all over 2 times a. All right? Then we're just going to do order of operations. Negative 4, anything squared, by the way, this b squared is always going to be positive. This is a negative and a negative, so that tells you that's going to be plus, all right? Anytime you have the minus and one of these is negative, you're going to have a plus there, right? So we have 4 times 3, which is 12, times 8, which is 96, all over 6, all right? The next step in order of operations is to combine these two. So we have 4 plus or minus the square root of 112 all over 6, all right? 112 doesn't have a perfect root, right? So we have 100, which is the square root of 10, and we have 121, which is the square root of 11, which means we know that 112 doesn't have a perfect root. So we are going to use our factor tree here. We know that 2 goes into 112. All right. So when we simplify this, a 2 is going to come out, a 2 is going to come out, right? So that means 4 is out on the outside, and we have a 7 left on the inside. All right, here's the thing. I can reduce this, but it has to come out of everything on the outside, all right? So I clearly cannot reduce anything with the 7 because it is on the inside. But I can reduce the outside as long as it comes out of every single piece of the outside. So what I am reducing has to come out of 4, 4, and 6, okay? Think of it as distribution. Take it out of the 2 pieces on the top and it can reduce with the bottom, all right? So what goes into 4, 4, and 6? 2. So I am going to divide every single piece of this by 2. I'm going to divide this by 2, I'm going to divide this by 2, and I'm going to divide this by 2, okay? It's just as if I had pulled a 2 out and had 2 plus 2 squared is 7, and I reduced that 2 with the 6 on bottom. That's basically what you've done, okay? It has to come out of every single thing on the outside. You cannot reduce just one piece of it. For example, had it looked like this, 4 plus 3 squared of 7 over 6. What goes into 4, 3, and 6? Nothing. I could not reduce that one. I can't reduce just the 3 and the 6 or just the 4 and the 6. Cannot do that. It has to come out of everything. I'm repeating this because this is the most common reduction problem that I see, okay? This is the most common mistake I see, is that you reduce one piece of a binomial and you can't do that, okay? So you can reduce it only if it comes out of all of it. So I can't reduce that one. This one I can because a 2 came out of all of it. So my final answer actually looks like this. Leave it just like that. 7 does not have a perfect root, so I can't add and subtract like I did on the other one. Because it doesn't have a perfect root, my answer is going to look just like that. That is technically 2 answers. It's 2 plus 2 squared of 7 over 3, and it's 2 minus 2 squared of 7 over 3. That's technically 2 answers for those, that plus or minus. All right?